So here we have to use the density of gold to determine the mass of a 25-liter sample of gold. So we want to end with mass, so let's end with grams. And we have a 25.0 liter sample. So 25.0 liters goes here. Now we want to cancel out liters and eventually make our way to grams. Now the only information we have about gold, and this is a physical property, is something that's not going to change. Gold is always, no matter how big or how small the sample size, it's always 19.3 grams for every 1 little milliliter. Or you could say it's 19.3 grams for every 1 little cubic centimeter. So if you had a little box, and it's a horrendous drawing here, but if you had a little box and the sizes were, or the sides were 1 centimeter by 1 centimeter by 1 centimeter, it would be 1 times 1 times 1, 1 cubic centimeter. That would have a mass of 19.3 if you put it on a scale, which would be way different than the density of other metals and substances such as water or alcohol or whatever. This is a physical property. Anyways, it's grams per milliliter, not liter. So we have to do a quick conversion here. 1 big liter is 1,000 little milliliters. Now we can throw in the density here. Now, a lot of times when kids see it with a slash and they see it all on one line, they don't necessarily see it as a conversion factor. So what I recommend you do is anytime you're given density of something, rewrite it. Write it over in the margin and write it like a conversion factor. Switch this slash to a horizontal line. And then it's obvious. 19.3 grams is equal to 1 milliliter. And if you need to, you can flip it upside down. Now in this problem, we don't need to. We want milliliters on the bottom. So we're going to put the 1 milliliter down here. Or remember that 1 cubic centimeter block. The mass, 19.3, goes on top. And then just do the math. 25 times 1,000 divided by 1 times 19.3 divided by 1 equals your grams of mass. So if you have a big 25-liter chunk of gold, it's going to have whatever mass you come out with.